Welcome to Pemaquid Point, which is in Maine. This is a state park and totally worth a visit. What you are observing is just extensive, remarkable geologic folding caused by compression.
We are at Pemaquid Point Lighthouse. We've been showing a series of folding. I want to show you some faults. So this dike right here, made of almost solid quartz, matches up where I put my cell phone right here. They used to be together and now they're separated. So the question is, do we have a dip slip fault or a strike slip fault? So we're definitely have a dip slip because I can draw my stick person. My foot wall would be over here. My head wall would be right here. Just draw your head here, your stick body. And you always determine a fault relative to the head wall movement to the foot wall. If this is the head wall and they used to be together, the head wall has been pushed up due to compression. That makes complete sense because we got an anticline right here. And so as you look at this, all folds are created by compression. And this is a wonderful look at how rocks can be deformed and then later on broken apart. So the faulting happened after the folds are made. The folds are made underground, under the Earth's surface, literally probably miles beneath the surface, for it to be pliable and be able to fold instead of break.
An interesting thing about Pemaquid Point is that you can see fold axes at the surface. So there's metamorphic rock and then igneous intrusions, and we're looking at some of those here. So you can see the rocks have been folded, even the layers. That's what the close-up view is. Here's an axis of a fold showing where a flat rock has literally been bent. That's an anticline. This whole section that you saw that was raised up with these rocks used to be about 7 to 8 feet taller based on the park employee that we talked to, and storms and wave action have worn it down. But these rocks are remarkable because it's such a radical amount of folding that occurred. So when did this happen? Back in the Paleozoic era, there were several times that we had plate collisions on this side of the continent. Likely, this uplift occurred as part of the Acadia orogeny. Looking at the intense wave action, these rock layers continue out into the Atlantic Ocean, and you can see how they're being worn down. But again, that layering shows the immense amount of pressure and folding that has occurred. In this little area, there was even small ecosystems and animals that were aquatic, that were living on these rocks, like vernal pools. But it was just a remarkable place to see because these folds are radical. In some cases, they've been overturned, so they're complex folds. And they're being hammered by physical weathering processes. So looking at these complex folds right here, they're really remarkable. So when you see the arch looking layers, those are anticlines, and the ones that sink down and kind of make a U profile, those are synclines. More to come. See you at the next stop. Bye.